Hi class, today we're going to be talking about solar radiation and where that energy goes once it reaches aisct's campus. We're going to talk about three factors. Those three are reflection, absorption, and lastly photosynthesis, which is closely tied to absorption. So when we talk about absorption, we're thinking in terms of energy. That energy stays on the surface that it touches. So basically that energy is absorbed. Reflection, basically our energy, or solar radiation, is reflected off back into the atmosphere, off of the Earth's surface. And we're going to study our own campus and try and figure out whether the energy is being reflected or absorbed off of a variety of surfaces. Those surfaces being the pavement, the trees and grass, and, lastly, the rooftop. Enjoy! In the next 4 steps of this lab, we're going to determine the scale of our map. In order to do that, we're going to head outside and figure out one landmark that we can measure that's on our map, determine the distance of that landmark, and then transfer that to our map to basically create a scale that tells us how large a distance we're measuring on our scale. For example, 1 centimeter on our map might correspond to 100 meters outside. We will see. The second step will then be calculating the area of each surface type. Those surface types are the pavement, the plants, and then the rooftops. Those are just the 3 surfaces we are going to calculate the area of. And then next, we're going to calculate the percent reflection and absorption depending on what amount of light is reflected and absorbed based on the 3 surface types. For example, the pavement will reflect and absorb a certain amount of light. Therefore, once we know how much pavement we have on campus, we can determine how much light is reflected and absorbed based on our pavement. And we'll do that for all 3 surface types. Next, we're going to answer the follow-up questions and last kind of summarize what we might be able to change at aisct in order to figure out a new way of constructing surfaces here that would promote more absorption of energy in terms of either plants or possibly solar energy and reflect less and back into the atmosphere. Next up, we will begin determining the scale of a map. This is the section of the map where we're going to head outside and determine the length of one landmark. So right now I'd like you to take note of a possible landmark you can see that would be easy to determine the length of and then correspond to a scale on our map. There's a couple things I can see that are rather interesting that might help us. Being highlighted right now is the basketball court. Possibly the pool, but we're not going to be around the water, so that's out of the question. And the next up, we have quite a few links around the school that might be useful, as well as the soccer field. And we'll head outside and determine one of those, depending on what you guys decide. On this slide, we're going to take our measurement of either the soccer field or the tennis court, or possibly a length to the outside of one of the buildings, and write in a scale. So somewhere on the side here, we're going to say 1 centimeter on our screen corresponds to blank meters on our map. This will help us to calculate the area of something such as our parking lot, or a rooftop, or possibly our trees. This slide merely illustrates what the different sections of our surface, basically our different surfaces around the aisct campus. Our rooftop over here, I think you guys will be able to pick out what is a rooftop. However, some places get a little tricky. For example, here at the back, there's a rooftop over our shed that basically provides the resources to fix everything at the school. Next, we have a garage where we have a lot of donated items. Over here we have a hallway that's a rooftop as well. So there's a few places where you might not notice rooftops. Also, where there's trees, we want to make sure we know that that is a plant and not pavement. So although you can see pavement in here in between the trees, we're not going to take the area of this entire parking lot because part of that is covered by a plant, and therefore the surface area is going to be plants. This section right here would be the asphalt or the pavement. This is the slide where you get to have a little fun. I want you guys to draw on this slide, create boxes and triangles to determine what amount of area we have that is a parking lot, what amount is plant, and what is a rooftop. For example, you can see that this area right here where I'm drawing the black triangle in the top left, that is all pavement. And now we can also determine that our base and our height of this triangle, as it has a 90-degree angle. When you're drawing triangles, please do use a right angle triangle. Therefore, we can use the equation 1/2 equals base times height. And that will, area equals 1/2 base times height. So 1/2 times base times height. Sorry about that. Area equals 1/2 base times height. That is correct. So triangles are one thing that we can use to help us determine the area. The other shape that you can use is a square. For example, on a rooftop, we could draw a square here, or a rectangle, and use area equals length times width. Go ahead and have some fun. Please delete my drawings if they are still present on this picture. And let's go ahead and determine the area of those three surface types. The pavement, the plants, and our rooftop. Good luck. This slide needs very little explaining, but what I'd like you guys to do is calculate the area of the aisct campus as pavement, plants, and rooftop. You were doing this on the last slide. I just want to see your work written out on this slide. This question takes a little bit more thought. The question is, what percentage of incoming solar radiation is reflected from the aisct campus if plants reflect 25% of light, rooftops reflect 75% of light, and pavement reflects 10% of light? Okay, so overall here, we're just trying to figure out how much light that's coming in is going to go back out into the atmosphere. And basically what you're going to do is take the percentage of light, or percentage of the aisct campus, I should say, that is one type of surface. Our example here is saying that the aisct campus is 25% pavement. Now this is just an example, this is not an actual calculation. Your answers will vary. So in order to figure out what percentage of our incoming solar radiation is reflected from that aisct campus percentage, we're going to take the aisct campus percentage and multiply that by the amount of light that pavement reflects, which is 10%, or in other words, 0.1. So you can see here that we have the aisct campus percentage, 25% pavement, and we're multiplying that by our reflection, which is 10% of light. Pavement does not reflect much light. It absorbs most light, especially asphalt, which is black. And so therefore, the percent we have reflecting back into the atmosphere is only 2.5% of what was coming in onto that surface. So over the aisct, 2.5% of the light that's coming onto the aisct campus in total, 2.5% of that is being reflected back due to pavement. And you're going to make this calculation for rooftops, pavement, and plants. So we'll just take us through this equation, and I expect 3 equations that look just like this in the example right below on this slide. Good luck, and when you have questions, please ask. All right, now we're on to the answering follow-up questions section. Please write down as much of your knowledge as possible in these sections, just like a test question. You're likely to see these questions again, and the more knowledge you put down on paper, the better information you have to study from, and typically the better your answer. So again, please write as much information as possible, and this applies to the next question as well on the following page. Okay, this is your last follow-up question. I'd like you to write at least 4 to 6 sentences answering this question. And this is basically applying knowledge that you have about how we can use solar radiation. I want you to use examples of plants. Plants use solar radiation. And from our last section on energy resources, that was 2 units ago, but please use the information from how we can create energy from solar radiation in your response as well. Hopefully that gives you enough of a hint to get started, and good luck. Congratulations on completing the aisct Solar Radiation Lab. You may now export this to a location off of this iPad. One great location is Edmodo. If that is not working, we will have to come up with another location to export it, possibly mailing it to Mr. Petoskey. Thank you very much, and if you have any issues, please ask me a question. Bye.